Today we're covering 2.8, which is linear inequalities. So in the previous chapter, we've talked about linear equations. Like a basic one might be x equals 2, where they generally have a solution, which is like a number. But inequalities that we're going to talk about today have a solution set. For example, if I look at x is greater than 2, there are multiple numbers that fulfill that. X could be 3, it could be 4, it could be 100. So that's referred to as a solution set. So for x is greater than 2, I can graph that on a number line. Here's 2, and then I'm going to put a parentheses here and shade in the area that's greater than 2. The parentheses is saying that it is everything bigger than 2, but it's not actually ever 2. And the way that we would express that in interval notation is to say that. We have parentheses and then we have 2 to infinity, because it goes all the way out to infinity in the positive direction. As another example, I could have x is less than or equal to -3. So then I'd go and find -3 over here, and this time I'm going to put a bracket. The bracket means that it can be equal to -3. And then in interval notation, my lower bound, I actually don't have a lower bound, so I'm going to call the lower bound -infinity, and its upper bound is -3. I could also have an interval where x is between two numbers. X could be greater than 2 and less than or equal to 5. So then I'd go and put that parentheses on 2 because it's greater than, and I would put a bracket on 5 because it's less than or equal to. And then that would be my solution set. And the way you would express that in interval notation is 2 with the parentheses, and then 5 with a bracket. And that says that x is anything from right after the number 2 all the way up to and including 5. So now we can get into solving some linear equalities. So there are just a few rules that are different than solving equations. For the most part, it's the same. So if I'm solving an equation like this, 2x is greater than or equal to 4, I'm going to try to isolate the x. And I can do the same thing as in an equation. I'm going to divide both sides by 2, and then I would have x is greater than or equal to 2. And I would get that same sort of solution as we did before. But if I had -2 is greater than -8. Now to get the x by itself, I'm going to want to divide by -2. And when you divide by a negative number, you have to switch the direction of the inequality sign. So now it's going to be x is less than 4, not x is greater than 4. Here's a slightly more complicated example, and all of the same rules apply when it comes to distribution and combining like terms. So the first thing I'm going to do is distribute the 6 on the right-hand side. And then I'm going to add 12 to both sides. And subtract 4x from both sides. That gives me 20 is less than or equal to 2x. I can divide by 2 again. And 10 is less than or equal to x. And I can flip this around and it will still mean the same thing as long as I get the sign the right way. So the x got the opening side of the equality over here, so I'm going to make sure that it looks the same on this side. And then I'll go ahead and graph this one and write the answer in interval notation. So that is 10, and x is greater than or equal to 10. So I'll have a bracket, and it's going to go all the way out to infinity. So the solution set is 10 to infinity. Now we're going to go through an example where we will solve an inequality that has 3 sides, basically. So in this case, I am not going to worry too much about these numbers. I'm just going to focus on isolating x. So first I'm going to distribute the 2. Then to get the x by itself, I need to get rid of that 2 in the middle. And so add 2 to both sides, and then divide out that 2 in front of the x. And notice that if I'm dividing or multiplying by a positive number, even if the number that I am dividing is negative, it doesn't change the direction of the sign. It would only be if the 2 down there was negative that I would have to flip signs. So this one is going to look like, here's -1, and here's 4.